Good afternoon. In the last session, we were talking about database models. Actually, like in this module 5, we have four data models. One is HBase, and second one is Cassandra, and third one is Pig, and fourth one is I. So these are the four data models that we will be discussing in module 5. And we have discussed about HBase, what is mean by HBase, what is called Hadoop database, and what is the difference between a row-oriented database and column-oriented database, and what is the difference between a relational database management system and non-relational database management system, and certain examples for this and that. And the basic idea is, whenever you talk about a relational database management system like RDBMS, right? So where for each and every I mean, you have three terms like table, row, column, and in terms of database management system, we'll be calling it as tuple relation, right? Tuple relation attribute. Relation is nothing but table. So here, and if I have a table with four columns, like name, roll number, branch, college name. So I know that this roll number column will be holding only the values in terms of integer type. That will not be holding some other type. Whereas if I talk about unstructured text, I mean non-relational database, or which is column-oriented database. So there a table that the value whatever it is going to hold in that particular table can be of any format. It is irrespective of data type. That is what we call it as unstructured text. And processing that data is little bit challenging. And that is where we require these data tools like HBase and these things, HBase, Cassandra, and these kind of data tools. And here I told you one more tool called Scoop, SQOOP, which stands for SQL plus Hadoop. What it does is, and it helps you to convert the data set from or convert a data table or data set from relational RDBMS to Hadoop database management system, and similarly reverse. So it can do both these two things. Okay, and we have seen one more thing like HBase architecture, and where that architecture we are compared with Hadoop architecture. Hadoop has two nodes. Hadoop architecture has two nodes. One is called master node. I mean, both it works in the format like a master and slave. Just give me a minute. Okay. So it works in the format like master and slave. Both Hadoop, I mean HBase as well as Hadoop architecture. So in Hadoop, we have master node that is called name node, and the other node that is called as data node. And we have only one name node, and we will be having multiple data nodes in Hadoop. Okay. In case of one data node gets failed, the other date you can use the other data node, so that where you can get the copy of the data, whatever it is being lost from the failed node, and fault tolerance can be reduced, and the data availability is more guaranteed in Hadoop as well as in relational database management systems. But once when you go for retrieving processing a data from a database, and column oriented database results much better than relational database management systems. Okay, and and here too HBase architecture works in the same flow, one as a master and the other as a slave. The master is called H master, the slave is called H region. And again, each master is going to be a single node, whereas each region can be multiple nodes. Okay, so each master is going to be a single node and each region can be a multiple nodes. I mean, how many number of each regions to get hold? If one or two, you need to partition based on the data size or based on the data set. You need to partition. Partition means like dividing it to blocks. That is called partition. Okay, that we'll be doing in like in map phase. So where I will be partitioning it, I will be dividing it into set of blocks. Once after doing that, once the blocks division has been done, then I need to make sure that my data fits into my database. In case, the advantage of this non-relational database is scalability. In case if you want any further data to be get inserted even when the blocks are getting filled, then we can create new regions under this again region server, and all the things can be get managed like in divide conquest strategy, or you can call like greedy approximation. Okay, so this is the basic idea behind HBase architecture, and the other one Hadoop architecture. In HBase, we'll be talking about what is mean by HBase and futures of HBase and advantages of using HBase and where to use HBase, where not to use HBase. Similarly, in the last module, we have MapReduce 1 and MapReduce 2. So what is the reason to move for MapReduce 2? What are the limitations with MapReduce 1 and how those limitations are being achieved in MapReduce 2? So in that way, like Hadoop is an ecosystem which offers you different tools, and in that we will be studying only about four tools in this module, and you should know the unique purpose of each and every data model, each and every data tool that we study. Okay, and the next topic will be HBase data model. We'll be talking about HBase data model. And there is one more term which you have discussed yesterday, that is called zookeeper, right? HBase uses zookeeper to make sure that at a time only one HMaster is running. See, to overcome from fault tolerance, to overcome from failure rate of nodes, what Hadoop does is Hadoop will be having one additional node that is called secondary node. Okay, secondary name node is this will get function once when main that once when the main node. Okay. Once when the name node get fails, then secondary node will be acting as a name node, will be doing its function. And similarly in HBase we have H master, and we have one more thing is called H. And wherever it is called HBase, it does mean Hadoop database. Okay, that is the meaning for HBase. And HBase a data model. So what are the things are there in a HBase data model? And when we talk about a data model, and first we should know what kind of data set or what kind of data it can process. What kind of data your data model can process. And this HBase data model can be used to process semi-structured data, to process semi-structured data in a faster manner. Just give me a minute. Okay. So, which is designed to accommodate semi-structured data, and in addition to that, this data model is little bit easy to partition the data, and where you can allocate it into different blocks across the cluster. And here we have different components. The components are again same, like table, row, column. But in addition to that, we have two things. One is called column family and one is called cell, and third one is version. And let's talk about all these components in the next slide. Okay. So you know what is called a table. Table is nothing but a logical collection of rows or logical collection of rows and values. Or it to be no, formally it can be called as like a relation which is representing you the relation between the rows and columns. And here in each base we have each region, right? In each base we have each region, and for each and every region it is being served by exactly with one region server. I'll be showing you a diagram in the next slide. And second one is row, and which will be holding an instance of a data in a table, which can be identified by a row key. And earlier when you talk about SQL, relational database management system, and where the data set a database will be get stored with respect to row oriented manner, and where you will be having a term called key, and further you will be having something called candidate key, super key, primary key, foreign key. And here we have only one key called row key. And further again, row key is a unique in a table. And column family means like, and here you can see this diagram. This diagram is being shown with five columns. But if you look into like heading, you can call that as like qualifiers. Okay, that column name can be called as qualifiers. And here first the row key is row key customer sales. When you talk about customer, that is being comprised of two columns. One is name and second column is city. That is called column family, where it is a combination or where it will consist two or three columns under a single column name. That is called column family. Okay, so where two to three columns shall be represented under a single column name. And if this is the case, how to access it? That is the next question. Like in SQL databases, I will be having a column name called name, roll number, branch, department. And if I want to access any particular value, I can do with respect to name, or I can do with respect to roll number. And here what to do is, like when you write a program in Java, when you do something with Java or Python, and if I want to point out to some methods within that particular object, then I should write that object name dot method name, right? So that I can point out to that particular method which is being stored under a pack. It can be a package, or it can be a class, or it can be in an object. Okay, and this concept we shall discuss at the end. This is not a part of your syllabus, but let us know how this works in object oriented programming. Okay. Okay, so I just want to access the values from my column, and which is a part of column family. And here the column family name is customer, and the column qualifier is name. And to access this, what I want to do is, first I want to write column family name. I need to write customer, and then I should use colon followed by the name of the column. Okay, so customer colon name. If I'm using city, customer colon city. If I use sales colon product, sales colon amount. In this way I can access the data, I can access the things from particular column with the help of column family. Okay, so it is a relation or a difference between column and column family. Okay, and next one is columns. Okay, and a column is identified by column qualifier. That's what I told you. The name of the column can be called as column qualifier. And when I want to use this, I need to concatenate this column qualifier with the column family name, and that syntax is given here. Family column family colon column name. and next part is cell, and it is the one which stores the data as what we call as fields, like as we call as fields in a database management system, and here we can call the same as cell. So it stores the data and which has a unique row key to identify each and every value, and that column name we will be calling it as column qualifier. Column qualifier will be the column name, not the family name. So column family name is different from column qualifier. Okay, and next one is version. So thereby you can know the version, what version that you are using with the database version that you are using. For example, see, when you execute a program in Java, you need to start something like a path setting or environment variables. And if you're doing the same with Eclipse, then that is different. You can execute the program either in a command prompt or you can do it in Eclipse. And if I'm trying to write a program to communicate with my Google Chrome, it can be web browser. I will be using HTTP protocol, and thereby I need to know the version of the Chrome that I am using. Right? I need to know the version of the Chrome that I am using, so that I can communicate to my web browser with the help of the program. Okay, so that is where the version support. That is where we need the version of a particular program or version of a particular tool in using the things. And when you if you take this topic in your syllabus, you can see something like the format of JSON. Just give me a minute. So if you take this topic in the textbook, you can see something called JSON format. It is called JSON. So JSON format. It is a kind of object notation, right? It is a kind of object notation where the program will be given in terms of C++ and Python. And mostly the programming languages that we use with respect to Hadoop or with respect to unstructured text, all the things will be support or will be having a column oriented data source, and all these things are like unstructured data set. Okay, and the last topic of HBase is HBase clients. So what are the different clients which rests on HBase? And again, HBase rests on top of Hadoop. And the first one is called REST. See, REST is a server. And what is the use of that server is which which provides the ability to interact with HBase from any of the programming language, and that is the need of REST. So which supports you the complete client which acts as an API. So whatever the programming language that you use to interact with this particular kind of application, you can use REST. Okay, it is a server, and REST stands for representative state transfer, representational state transfer. That is the meaning of REST. RE stands for representational, S stands for state, T stands for transfer. Okay, so that is the meaning of REST. So which helps you to interact with HBase from any programming language. This you can call as you can just treat it as like an API. Okay, so which comes with a package and which is located in org.apache hadoop.hbase.rest.client package. And to know little bit more about these things, what you can do is you go to Eclipse and type a simple program using Java. So thereby where you are going to interact with a database, or you can get some example programs. So once if you are using the methods which is being supported by REST, so thereby once if you click that particular method, you can get these things like import org.apache hadoop hbase. So thereby where you can get the support of these libraries from the packages. Okay, so that is the need of REST. To be short, REST is a API. which supports you to interact with HBase, and it is irrespective of the programming language that you use. Either you can use Java, C++, or Python. And mostly in the examples and the case studies that whatever we will be discussing, the example that they have used is Java, mostly 80% Java, and then Python, and then in few cases C++. And we'll be talking about one more client that is called Thrift, and which is being entirely written in C++. Let's talk about Thrift. Okay, so this is second one is called Thrift. It is called Apache Thrift, which is written in C++. And what is the use of this is Thrift is a software framework which allows you to create cross-language bindings. That is the main purpose of using Thrift, cross-language bindings, and which provides you a schema compilers for many programming languages like C++, PHP, Python, Ruby, and many more. And once if you have compiled a schema, you can exchange messages transparently. I mean, whereas the last one, REST, what it is doing is it is acting as an API through which we can interact, through which we are interacting with each base. And what this Thrift does is it helps you to bind. That is bind means like linking. So it is compiling, linking the schema with the language that we use. So, okay. So that is the meaning of Thrift. And third is one is called Apache Avro. And again, you need to note one more thing. See, HBase is a HBase is a column-oriented data model, and Hadoop NoSQL it is a column-oriented data model. But we will be talking about Avro with respect to HBase, but Avro is a row-based. Okay, Avro is a row-based storage format that you should be noting. So Avro is a row-based storage format for Hadoop, and we use this mostly in serialization platforms. So there we use mostly the serialization platform. And regarding serialization in Hadoop, we have talked in module 3. So what is called serialization, and what is the use of serialization with Hadoop that we have discussed in module 3. And there also we have used this term called Apache Avro, and even you can use this Apache Avro client with HBase. Even though this HBase column oriented, we can use Avro in support to this. Avro is a row-based storage format for Hadoop. Okay, what it does is it stores the data. It stores the data in JSON format and makes easy to read and interpret the database or data set by using any programming language or even using any kind of tool that is provided by Hadoop ecosystem. And I just want to tell you about one more tool which Hadoop ecosystem offers, that is called Apache Ambari, AMBARI. It is again an API. It helps you to monitor your Hadoop file system. It as like an interface. So that is an API which will be acting as like an interface and which will help you to monitor the things happening with respect to Hadoop, for example. So as we're talking about H region, we are talking something called H master. We'll divide this into set of blocks, partitioning, right? So I can say that my system, my data set, my database will be divided into, or my problem will be get divided into cluster of blocks where it will be holding set of blocks, right? And in this I can use a term called node, even that we have taken as Z node. Each region can be called as Z node, that is zookeeper node. Okay, and to see that how many number of nodes are there in my system, I can use Apache Ambari API, or I can use Yarn, Hadoop with Yarn. We have discussed MapReduce with Yarn, but even Hadoop can be used with Yarn. So thereby you can know how many number of nodes are totally are there in your system, Among that, how many number of nodes are currently executing, how many number of nodes are failed, how many number of nodes are not executing. That you can visualize as an interface. Like it will be showing you in a screen. It will be displaying you the status in a screen. Okay, like an API. So where you need not to command, you need not to interact with your system with the help of command each and every time. Once when you start it, so thereby you can monitor it with the help of these APIs. Okay, so once after completing this class, when you get free time, just go to Google and type Apache Ambari, and you can see some interface screens. Like for example, what you can see once if you complete your projects. When you do your academic projects, so at the back end you will be using a programming language. Front end you will be using a tool which makes you to give the visualization in a simpler manner. Similarly, these APIs interfaces are just your front end design tools, whereby which will be assisting you to track the things happening in the background. Okay, so that is the need or support of these tools like Apache Ambari, Apache Avro, and even the other thing like Yarn. So so we will be using these things in those applications. Once when you start doing some applications using Hadoop or MapReduce, then you will be getting little bit idea about all these things. And in the textbooks, reference textbooks, you can see one textbook called Hadoop Essentials. That is the name of textbook. I mean Essentials on Hadoop. And that textbook will help you to learn about these things. But this is not in your syllabus. But it is needed. You need to know these things once when you talk about these particular tools with respect to Hadoop. Okay. So that is the use of Apache Avro. And next, there are few other clients like JRuby and HBQL, HBase, JP. And let us see short about all these things. So first one is called JRuby. So it is again you can treat as like a programming language which supports in binary format. When you try to do something with respect to binary formats in HBase, where you can use JRuby. Okay, so you can see this the HBase shell is an example of using a JVM, so whereby you can add some futures. And second one is called HBQL. SQL stands for structured query language, right? Similarly, BQL stands for browser query language. That is the meaning of BQL, browser query language. When it is used in respect to Hadoop, it is called Hadoop browser query language. And here we will be using a term called HBQL, that stands for browser query language. And it is same as like SQL. It is same as like SQL equal to database, but whereby you can use these things when you start interacting when you're talking with respect to a browser. So thereby you need to talk about protocols. Okay, and the next term is HBase DSL. So this is used in HBase clusters, and where you can assemble all the parameters that which is required to process in your system. And next one is called JPA or JPO. We have a term called JDBC or ODBC, and here it is called Java Persistence API or Java Persistence Objects. Okay, and there is something called data nucleus. So to learn about this, you need to know about something called Google File System data format, and they use a term called big table data format. We call it as big table, right? So when you talk about the Google file system, Google uses a distributed file system, which is called DFS, right? So Google uses a distributed file system, and even when you talk about Facebook, Twitter, Orkut, all the social media uses these kind of tools in processing the data that whatever that they are getting in a fraction of time. I mean, hardly they're getting more than 1 petabytes of data in a fraction of second. The social medias like Facebook, and where you need these kind of tools in extracting the information. And next one is PYH based project. So they've given you a link where you can get access to the information about this particular Python based project. And the other client is asynchronous, so which offers you a completely asynchronous non-blocking thread states. So when I talk about this asynchronous non-blocking, this works or this is being used with respect to RPC, that is called remote procedure call. So when you take a topic inter-process communication in operating system, you will be talking about four things like a blocking send, blocking receive, non-blocking send, non-blocking receive, and there is one more condition called render source. So there we talk about a remote procedure call, where you will be linking certain call or method to a program, whereby you will be trying to execute that program in a remote manner. Okay, so these are a different. These are various clients that is being supported with HBase. Okay, the most important clients are one is REST. That is the most important one. Second one is Apache Avro. Okay, so REST, Apache Avro, and Thrift. So these three are the most important things. And next to that, the other important things are one is BQL, that is HBQL, and second one JRuby. So these are various important clients that comes with HBase. Okay, so this is about Apache HBase. So I will just repeat the subtopics that whatever that you want to study under HBase. First thing you need to talk about what is mean by HBase, a definition of HBase, meaning of HBase. And second, in addition to that, you need to know what is the future of HBase. And next one, HBase architecture. You need to talk about two things. One is HMaster and second one is H region. You need to talk about write ahead logic. That is where you call H log. Okay, that is where you called H log. And next term, zookeeper. Okay, and next about HBase clients. There, at least you should talk about REST, Thrift, and Avro. And then other clients you need to talk about JRuby, BQL, HBase, DSL, JPA. Okay, so these are the subtopics in HBase.